I want to walk you all through a quick review of real numbers. This was something that we learned early in chapter 1, and this is just a quick glance over so that you guys are a little better prepared or feeling a little more confident with what you'll be asked on the midterm next week. All right, so all numbers are real numbers. We categorize real numbers as either rational or irrational. Rational numbers, in a nutshell, can be written in the form of a fraction. Irrational numbers cannot be written in fraction form. Most of the numbers that we work with, though occasionally we do work with irrational numbers, but most of the numbers that we work with are, in fact, rational numbers. Rational numbers can be categorized or broken down into three sort of more detailed specific categories. Natural numbers that include numbers starting at 1, 2, 3, on and on and on and on. Whole numbers that start at 0 and then go on 1, 2, 3, and up further into the positives. And then finally, integers, which take us into negative values. So -2, -1, 0, 1, 2, on and on in both directions. Notice that for our integers, and what we use as a definition for integers, they are the opposite of all of those whole number values. Examples of some examples of some rational numbers. You're going to see a combination here of whole numbers, natural numbers, integers, and you're also going to notice that there are just some random fractions, decimals, there's even a square root there. So something like 1/3, we classify 1/3 as just a real rational number. It doesn't fit into the category of natural, whole, or integer, but it's still considered to be a rational number because it's a fraction. A number like 3.175 or -10.4. Those are decimals. We don't call them decimals when we're classifying. We simply call them rational numbers. Notice that the square root of 16 is on our rational number side because the square root of 16, we know that the square root of 16 is 4. Well, 4 is certainly rational because it is natural, it's whole, and it is an integer. In our rational number column, I gave you just 2 examples here. Pi is an example of an irrational number, mainly because we know that pi is a decimal that'll go on and on and on with no seeming pattern to it. It's never going to end. It's infinite. The square root of 10 is on the irrational side because 10 isn't a square number. So we can figure out that the square root of 10 would be somewhere between 3 and 4, but we won't know exactly what it is. We know it's going to be a decimal that goes on and on and on. And that's just a quick review of real numbers and how we classify numbers. See you next time.